Let's look at composite functions. Composite functions, we say, is a function within another function. So, for example, say I have a function f of x is equal to x plus 3, right? And let's say I have another function g of x, and g of x is equal to x squared, right? I can find the function f of g of x, which means that I am going to place g of x within the function f of x, right? So if I have to find f of g of x, what I am essentially doing here is I am finding out what the function f of x would be equal to when I substitute g of x into it. Now remember, g of x is x squared. So f of g of x is the same as finding out what is f of x squared, because g of x is equal to x squared. So let's see what f of x squared is. Well, if you recall, to find f of x squared, I would have to replace x with x squared in the function f of x. So everywhere I have x in this function, I'm going to write it over just for ease, right? F of x is equal to x plus 3. If I need to find out what f of x squared is, everywhere I have x in the function f of x, I will replace it with x squared, which is why I wrote x squared here already. So here I have x, I'm going to replace it with x squared. And then, well, I keep the 3 because that's still part of the function. And this is the function f of x squared. So therefore, f of g of x is equal to x squared plus 3. In a similar way, I can also find out what is g of f of x, right? So g of f of x is the same as finding out what g of, well, f of x is x plus 3. So g of f of x is the same as finding out what is g of x plus 3. And therefore, what I will do here is I will substitute x plus 3 into the function g of x. So wherever I have x in that function, I'm going to replace it with x plus 3. So g of x plus 3 is equal to, well, g of x is x squared. So I replace x with x plus 3. Now I can't get rid of the squared, right? Because that's what the function is. The function is x squared. So now I have x plus 3 squared. Now you can leave your answer like this, or you can expand your brackets, right? X plus 3, all to be squared, is not x squared plus 9. It's actually x plus 3 times x plus 3. And I have another video on how you expand these brackets, so I'm just going to do it quickly here. X times x is x squared. X times 3 is 3x. 3 times x is 3x, and then 3 times 3 is 9. So this would be equal to x squared plus 6x plus 9. Therefore, remember, x plus 3 is f of x. So g of x plus 3 is the same as g of f of x, which is equal to x squared plus 6x plus 9. Okay, let's check this one out. If f of x is equal to 2x and g of x is equal to x minus 3, find A, f of g of x, and B, g of f of x. So the first part A, we're going to find f of g of x. Now, remember, they gave us that g of x is x minus 3. So finding out what f of g of x is the same as finding out what f of x minus 3 is, since g of x is equal to x minus 3. So therefore, in the function f of x, which is equal to 2x, I am going to substitute x minus 3. So I'm going to write over the function f of x is equal to 2x, which means 2 times x. So finding f of x minus 3, we will just replace x. Wherever I have x in the function f of x, I will replace it with x minus 3. So this will be f of x minus 3 is equal to 2 times x minus 3, because that's what 2x means. 2x literally means 2 times x. Now you can leave your answer like this, or you can further simplify it by removing the brackets. So you say 2 times x will give you 2x, and 2 times minus 3 gives me minus 6, right? Now for part B, we need to find out g of f of x. Now g of f of x is the same as finding out what g of 2x is, because that is what f of x is equal to in this question. So let's write over the function g of x. G of x is equal to x minus 3. Therefore, to find g of 2x, wherever I have x in the function g of x, I will replace it with 2x. So here I have x, I'm going to replace it with 2x. All right, and that's your answer. So f of g of x is 2x minus 6, and g of f of x is 2x minus 3. Let me write it in. F of g of x is equal to 2x minus 6, and g of f of x is equal to 2x minus 3. All right, let's look at this example. It says if h of x is equal to x squared and k of x is equal to x plus 3, find k of h of 4 and then h of k of 5. Now there are two ways to do this, but the easiest way to do it is to find out first what h of 4 is and then substitute that into the function k of x, right? The function that is inside here is the one that you're substituting inside the outer function. So we need to find out what h of 4 is, which is quite simple. Since h of x is equal to x squared, h of 4 would be equal to 4 squared, which is equal to 16. So therefore, k of h of 4, k of h of 4 is the same as finding out what k of 16 is going to be. So we recall that the function k of x is x plus 3. I'm going to write it over. When I'm doing functions, I like to write over the function as much as I can so I could see it more clearly when I'm doing my substitution. So if k of x is equal to x plus 3, k of 16 would be equal to 16 plus 3, which is equal to 19, right? So that's your answer for k of h of 4. Now for h of k of 5, it means we are substituting k of 5 into the function h of x. So the first thing we need to do is find out what k of 5 is equal to. So let's see. Let's write over the function k of x. K of x is equal to x plus 3. Therefore, k of 5 would be equal to 5 plus 3, which is 8. And now we can substitute that 8 into h of k of 5 because we know that k of 5 is 8. So finding h of k of 5 is the same as finding out what h of 8 is because k of 5 is 8. So let's see. The function h of x is defined as x squared. So we need to substitute 8 in there. So h of 8 would therefore be equal to 8 squared, which is 64. So therefore, k of h of 4 is 19, and then h of k of 5 is 64.